Okay, I think now, everything is good. I think everyone can hear me now. We're good to go. I'm just gonna wait for your comments so that you guys can tell me if you can see the screen. If you can see, then we can start. I'm waiting for your comments, my people. Please tell me if you can see and if you can hear me. Then we can start learning, because that's why we are here in this lesson. We are here to learn. Thank you very much for confirming. Thank you very much for confirming. Okay, now we can start. We're going to start with an incline problem. We're going to start with an incline problem now. So what we're going to do is that we have this box that is on inclined, and now I know that most of the time we work on when the force is applied horizontally to the surface. But now look at this. I want us to do this things differently this time. We're going to apply the force on incline at an angle. I'm not sure if you guys can see that, but let me try to fix my incline. Let's put it like this. Okay, so this will be my incline. Right, we're going to put a box like this that is applied at an angle. Right, so I'm just gonna put all the information that we need here. I'm going to put all the information that we're going to need to answer this question. So now this box, it has a mass of 50 kg. The mass is 50 kg, and it is applied at an angle of 20 degrees. Okay, and now the F applied, the force, the F applied of this box is 600 newtons. Okay, so everything is good. So now listen. Now we have the angle between for the horizontal, and we also have the angle for the incline. So this angle for the incline is 30 degrees. We're going to discuss everything that you need to know based on this problem. Okay, so this problem, we said that an object is pulled up an incline at an angle of 30 degrees to the horizontal, and the applied force of 600 newtons acts at an angle of 20 degrees. Okay, so now the object accelerates up the incline at 4.62. So this object, it accelerates up, and the acceleration is 4.62 meters per second. This is what we have so far, and we're going to use this information that we have. We're going to find the following. They want us to determine the coefficient. The coefficient of kinetic friction. This is the question. Everyone can see the diagram. So we're going to go through this problem. So we can see that this is what we are given. We are given an object that is on inclined, and they want us to find the coefficient of what? Of kinetic friction. That's what you are given as the object accelerated up. So we need to find the coefficient of kinetic friction. So now, listen, this is very important. First thing first, when you answer the question, this type of questions, you know what I need you to write down first? They want us to find the coefficient of friction. So this tells you that we need to bring the formula that has to do with coefficient of kinetic friction. What I'm trying to say, go to your formula sheet, choose the correct formula. So you go to your formula sheet, you'll find that Fk. So the Fk, the kinetic friction, the formula that we use is the coefficient multiplied by the normal force. I think this makes sense, né? Okay, I think this makes sense. So we have Fk is equal to the coefficient times the normal force. So what you need to do now, you're going to ask yourself, that, do we have this Fk? Nope, we don't have the kinetic friction. So that's the first thing that we need to find. Do we have the normal force? No, we don't have the normal force. So we need to find the normal force, we need to find the kinetic friction. So when we have these two, we'll be able to isolate the coefficient of kinetic friction. So it's very important for you to know where to start. So what I'm going to do from this is that, first thing first, I need to find my Fk. I can find my frictional force, I can find my normal force, okay? So let's start with the normal force. Remember, the normal force always acts up. This is my Fn. Then the force that will act in an opposite direction of the normal force is our Fg. But remember, this thing is on inclined. This will be Fg perpendicular. So now what I'm going to do is that, let me put this information here and say Fg perpendicular is equals to mg the cos of theta. Fg parallel, this is the weight that is parallel to the surface. This will be equal to mg the sine of theta. Okay, so now what we're going to do, we know that the normal force, if we draw a free body diagram, if I draw a free body diagram indicating my vertical forces, look at this. I'll have the normal force going up. This is my Fn, and I'll have my Fg perpendicular going down. This is my Fg perpendicular. So what I'm going to do, I'll take up as positive, and these forces will have the acceleration of 0. So I need to find F net. So I'm going to take F net for vertical forces. Let's equate this to 0. Remember, guys, I promised you to move slow, ne? Let me try to move slow so that I don't fight with you, ne? So F net means that we need to add all the forces that are going up, then we subtract all the forces that are going down and equate this to 0. So the normal force will be equal to what? Fg perpendicular. So the Fg perpendicular will come on the other side. So this tells us that to find the normal force, we'll use Fg perpendicular. Now we know what is Fg perpendicular equals to. So we just have to substitute that Fg perpendicular. So we just have to substitute this guy here. This is my Fg perpendicular. So this is what I'm going to substitute. Right. So now, where does Fg perpendicular? Let me quickly put mg the cos of theta. That's what we're going to use to find the normal force. That's what we're going to use to find the normal force. But now, there's one force missing. Can someone please tell me on the comments? We are missing one force. Remember, this is the force is applied at an angle. So normal force will be reduced. Can someone please tell me which force are we missing on the comments? Which force are we missing? Because I forgot that the normal force, you see, this is the same mistake that you can make when you are in an exam. Listen, look at this. The force is applied at an angle. There's one force that we are missing on this free body diagram, and we need to include that force. Which force is that one? I'm waiting for you guys. The force is applied at an angle. Now, can someone tell me which force are we missing? I don't understand from calculating parallel lines. Evenly says frictional force. No, we are not missing a frictional force. Frictional force is not a vertical force. Ne? Frictional force is a hot. A lot of people are saying we are missing frictional force. No, guys, frictional force is not a vertical force. I need the vertical force because we forgot to include one vertical force when we draw this free body diagram. So this tells you that when the force is applied at an angle, there is a force that will reduce the force of gravity. Which force is that? Gravitational force. No, Soli. No. Come on, Soli. Someone is saying tension. We don't have tension. Get in, Omogolo. Thank you very much. F-A-Y. Thank you very much. Ne? Thank you very much, Omogolo. That's correct. Guys, not friction. You see why it is important for you guys to attend this lesson. So now remember, if a force is applied at an angle, no, it can't be Fs. It's going to be F-A-Y. So if a force is applied at an angle, we're going to have what? The horizontal component, which is my Fx, and the force that we are missing here is the Fy. The horizontal is the vertical component. We are missing the vertical component. We were supposed to include Fy, which is going down. I'm just going to put it there. This is your horizontal component. Let's put it here. Fy, it's equals to mg, the sine of theta, and Fx, it's equals to mg the cos of theta. These are our vertical and our horizontal component. So what we are missing here is that we need to start this thing from scratch. Now, I'm very sorry about that. I just forgot that the force is applied at an angle. So if the force is applied at an angle, we're going to have 3 vertical forces. So if we have 3 vertical forces, what we need to do here, we need to subtract. Remember, Fy is also okay. Let's do this. I think it's best if we just erase this part so we can fix our mistake. I hope you guys understand what happened here. We missed a vertical force, and that is Fy, and Fy is mg, the sine of theta. Okay, so now what we're going to do is that we're going to say F net we take up as positive, we add the normal force and our Fy because they are going up, then we subtract all the forces that are going down, which is Fg perpendicular, we equate this to 0. Right, so when we have it like this, we need to make the normal force subject of the formula. This tells us that Fn will be equal to the Fg, will move to the other side to be positive, then we're going to subtract the Fy. So remember, if a force is applied at an angle, there is a vertical component that will reduce the weight, which means it reduces what? The normal force. If you understand that part, you are good to go. So what you need to do now, to find your normal force, we need to say this will be my Fn, it's equals to Fg perpendicular, we said it's mg, the cos of theta, minus Fy, we said, come on guys, you see now, why are we making so much mistakes? Like, This is not mg, it's fa. It's fa, the f applied. It's fa, the sine of theta, fa, the sine of theta. Come on, guys. When I make, yes, thank you. It's fa, say, use. Yes, thank you, guys. You see now, I'm happy when I make a mistake and I see that you guys are trying to correct me on the comment. Someone is asking why is fnet equal to 0. Fnet is equals to 0 because Fnet is equal to 0 because this is horizontal component, so the acceleration is 0. I'm sorry, is the vertical component, so the acceleration is 0. So Fnet, for when you deal with vertical component, just say Fnet is equal to 0. Thank you, guys. For those who just corrected me that this is FA, thank you. Next. So now this will be FA, which is the F applied. We're going to multiply this by the sine of theta. Now, we know what is normal force equals to now. Let us leave that equation like that. We are coming now. I don't want us to punch this yet. Now we know the formula that we need to use to find the normal force. We know the formula that we need to use to find the normal force. I'm just going to leave that formula like that. So now, what about the frictional force? What about the frictional force? Because now we know the formula that we can use to find that guy. What about the frictional force? You know what I'm going to do? Frictional force is the horizontal force. I'm going to have a frictional force, which is my Fk, moving down. Then we have I'm trying to indicate all the horizontal components. So not the forces that are parallel to the surface. Then we have this one there, which is my Fx. Then there's this other force that always acts down. And that force, we call it Fg parallel. So all those forces are the forces that are parallel to the surface. So my free body diagram will look like this. Let's indicate it like this. Let's put a box here so no one will be confused. Let's put a box like that. Okay, so now we have the Fx moving up. We have the Fk going down. What else? We have the Fg parallel. So now we can use the formula saying Fnet is equals to Ma. Why is this equals to Ma? Because these are the horizontal forces. Right. So now what we're going to do is that we choose up as positive. So if we choose up as positive, we're going to take all the forces that are going up. We subtract all the forces that are going down. And this is equal to 0. So now, what is Fx? We know that Fx is equal to Fa, the cos of theta. So this will be Fa, the cos theta, we minus Fk, which is the one that we are looking for. We minus Fg. What is Fg parallel? It's equals to mg, the sine of theta. And let's equate this to 0. So now, therefore, what is my frictional force? Listen, Fa, I'm just going to leave the Fa, the cos of theta, like that, minus this with the mg, the sine of theta. Then let's bring the Fk this side to be positive. So now, the good news is that we know what is Fk equals to. You see, if you can manage to understand what we are trying to do here, we are trying to find the formulas that we can use to find our Fk, and also the formula that we can use to find our normal force. So trust me, if you understand this step, everything, you are good to go. If you understand this part, you are good to go. Trust me. Guys, before I continue, are you all happy with this? Do you understand how we got these two formulas? And if you have a question, please make sure that you ask your question now. Are you all happy? I don't understand. Moloko, which part you don't understand? So let me try to explain this again. Because the only thing that you need to understand is the free body diagram. Very happy, sir. Two slide. Tell me. Guys, don't tell me that we made another mistake. You see. Fy, it's fa the sine theta. A little bit. I don't understand that step. Which one? The one that we were currently working on. Guys, don't worry. We can go through this again. Don't worry. But one thing I need you guys to do is to make sure that you understand where is that. I just need you guys to do me a favor, né? Fg parallel is mg the sine of theta. Okay, I just want to confirm. Someone said Fy is not Fa the sine of theta. Why are you saying Fy is not Fa the sine of theta? No, it's Fa the sine of theta because it's opposite all over hypotenuse. We'll use sine theta. There's no mistake. Yes, I see there's no mistake. We didn't do any mistake. Everything is correct. I just want to accommodate those who don't understand so that we can repeat the process. Because the only thing that you guys are saying is that you don't understand the free body diagram. So if you don't understand the free body diagram, you're going to have a problem. This tells me that you can't identify all the forces that are acting on the object. And if you can't identify all the forces that are acting on the object, you're going to have a very serious problem. So in order for you to master Newton's law problem, know which forces are acting on the object. Are the forces going up or down? That's what you need to understand. The horizontal component is not cos. The horizontal component is sine, not cos. Guys, why are you saying that the horizontal component is cos, not sine? The horizontal component is cos and the vertical component is sine. Please, guys. I don't understand the formulas. The horizontal component is sine, not cos. There's no mistake. No, we did not make any mistake. Né? The frictional force is applied. The cos theta, we're going to minus mg the sine of theta, and so on. Right, but now, guys, there's something. Yes, there is a mistake. Né? The only mistake that we made is this part here. You know, guys, no one is perfect. Né? When I make mistakes, I celebrate because those mistakes they'll make me to be the best. Now remember, we learn from our mistake. The mistake is that we forget that we are working with what? We are working with Newton's second law. There is acceleration. We can't equate this to zero. So that's the only mistake we made. We can't equate that to zero. What I'm trying to say, remember we said the F applied is equal to what? The F applied is equal to acceleration, the mass times the acceleration. So this is the mass. What is the mass? It's 50 inside the bracket, but we are coming to that. Né? Let's just leave this as MA. So this will be MA. This will be MA. Then we minus FK. It's equals to MA. Come on, guys. Moloko. Now you see, now we are telling you that Fy, it's sine. You still saying it's cos. Tell we can't move if you don't agree with us. We are telling you it's called the vertical component we use sine. So now I have to prove it to you. Why are we using sine? It's fine. Let me explain why we are using sine. If I have this F applied, and then this force is applied at an angle, we're going to have what? We're going to have a Fy going up. This is a 90 degrees. Therefore, this is my Fx. So I have my opposite, my hypotenuse, and my adjacent. So I am looking for what? I'm looking for Fy, and I have Fa. So I have, if I use the saw cato, we have the opposite and the hypotenuse is going to be the sine of theta is equals to my opposite, which is Fy, all over my Fa, hypotenuse. We make Fy subject of the formula by multiplying both sides by what? By Fa. Therefore, what is Fy equals to? So this cancels. Fy is equals to Fa, the sine theta. You see why we are saying that this is Fa, the sine of theta. Moloko. Right. I just wanted to explain these two formulas. If you are happy with the formulas, we can continue now. So we're going to take this step by step. Now. Don't worry, we're going to take it step by step. Then you guys will understand. I just wanted you to be able to, you need to know how to use those formulas. Now. It's very important. Because if you know how to use the formulas, everything will be easy for you. Right. So now, you know what I'm going to do? I'm going to try and attack this in a different way. Then you guys will tell me which method you prefer. Because now, if we have these two, we know which formula we can use to find the Fk. We know which formula we can use to find the normal force. Né? So what I'm going to do is that I can calculate this thing separately, but if I calculated them separately, sometimes we might make a mistake with the rounding. So when we round off, we're going to make a mistake. So you know what I'm going to do now? I'm going to say, now I need to find my Fk. Let's start with Fk. Let's work with this formula here. We have Fa, the cos of theta minus mg, the sine of theta minus Fk, and this is equals to ma. So what I'm going to do is that I need to substitute what I'm given. The applied force was given as 600 Newton. The cos of, please be careful. You see this thing. This is your Fx. So if this Fa cos theta is your Fx, which angle are we using? Please don't use this angle. It's wrong. We use the angle for the applied force. Which angle is the applied force? Which angle is for the applied force? The 20 degrees. So this will be the cos of 20. We're going to minus. We set the mass is given as 50. G is 9.8. The sine of what is your theta? Remember, this one, mg, the sine of theta, it's what? It's FG parallel. This is your FG parallel. And which angle are we using? We're going to use this angle, the 31, the one for the inclined. You need to be very careful. So I'm just going to put a note here so that no one forget this. FG perpendicular and FG parallel. Remember, FG perpendicular is mg, the cos of theta. This is mg, the sine of theta. So this one, we use the 30 degrees, and then we have Fy, it's equal to Fa, the sine of theta, Fx is equal to Fa, the cos of theta. These two are for the applied force, and then we're going to use a 20 degrees angle. Please, though, do not make a mistake when it comes to that. Né? That might affect the final answer. Right, I see everyone is happy with that. The angle that we're going to use, this is one will be 30 minus Fk, which is the one that we are looking for. It's equal to the mass, it's 50. The acceleration was given. Remember, the acceleration is given as 4.62. So I'm going to substitute acceleration to be 4.62. Therefore, now, the only thing that we need to do is to find our Fk. So we can say this is 600, the cos of 20 degrees minus 50 into 9.8, the sine 30, then we minus 50 into 4.62. It's equals to Fk. So what I did, I just moved the Fk to the other side, then we move the mass times the acceleration to the other side. So we take this part here, we move to the other side, it changed the direction. Then we take this part here, we move it to the other side, it changes the sign, not the direction, but it changes the sign. Eh? So when you have something like that, you can just punch that long thing on your calculator to find your Fk. So I need you guys to give me the answers on the chat box. Please tell me what you guys get. What is the frictional force equals to? Put it on your calculators, guys. Tell me what you get. Yo, Kanyisa, what did you do? 567.31. Guys, is that correct? Guys, let me also put this on the calculator. Okay, so Nolo, thank you for the correct answer. Mr. Tromza, thank you for the correct answer. So the correct answer is 87.82. Guys, please practice how to use your calculators. Please, 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 guys. But I really appreciate you guys for sending your answers. So the correct answer will give us Fk at 87.82. Thank you very much. So this will be 87.82 newtons. So we have frictional force. We need to use this formula here to find what the normal force. So let us rewrite that formula down. Then we're going to work on it and find the normal force. I'm just going to rewrite the formula. Fn, we said the formula is Fn. It's equals to mg, the cos of theta, minus Fa, the sine of theta. That's our normal force. Let's just go and substitute. Fn is equals to, where there's m, I'm going to say this is my 50 into 9.8. Remember, this is our FG perpendicular. So which angle are we using? 30. So this will be the cos of 30 minus F applied 600 newtons, the sine of, this is our Fy. So we're going to use 20 degrees. So when we punch that on the calculator, you know what I need you guys to do? I know that we're going to get a very long decimal. I'm not going to punch the calculator because I'll make a mistake when I do the rounding there. So now we need to rewrite this formula down there. Let's go back to the formula. Let's go back to the formula. We know what is Fk. We know what is normal force. I'm just going to rewrite my formula down and say Fk is equal to the coefficient times Fn. So we calculated Fk to be 87.82. It's equal to the coefficient. Inside the bracket, I need to put everything down. I'm going to say this is 50 into 9.8, the cos of 30 degrees. We minus 600 sine 20. I hope everyone can see that, but we're going to rewrite the equation down here so that you guys don't get confused. This is 87.82 is equal to the coefficient of 50, 9.8, the cos of that 30 degrees, minus 600, the sine of 20. Guys, my students, most of people who have lessons with me, they will tell you that we work and we get those distinctions. Né? So now we're going to go through this thing. I'm going to show you what is important for you to know. We're going to discuss the tip, why am I doing this? Né? So look at this. Look at this. We need to divide everything. So the coefficient will be equal to, we need to take the 87.82. We need to divide it by that long equation of 50 into 9.8, the cos of 30 degrees, minus 600, the sine 20 degrees. So I need you guys to punch that on the calculator and tell me what do you get as your coefficient. 0.4. Someone got 0.4 and that's very correct. Thank you very much. Next. 0.4, we don't have any SI unit for that. Are you guys happy with how we solve this? Sipo, where do you get 219.14 newtons? No, remember this is the coefficient of kinetic friction. We don't even have an SI unit and it's small, it's 0 point something. It's always 0 point something. You see? So 0.4 newtons. Thank you, to slide. So it's very important that we continue doing these sessions because I can see that most of you guys need help. Né? Most of you need help. So these lessons will improve your marks. We need to work towards that goal mark of 70% and above. Yeah, Katlego, I see you are saying that you are very happy. Né? So let us go back and try to accommodate those who don't have. Let's go back and try to accommodate those who don't understand. Né? Guys, you don't have to be scared and say this question is long. Hey, what? Listen, in an exam, they'll never ask it like this and say, determine the coefficient of kinetic friction, what. No, they won't ask it like that. They'll start saying, calculate friction, you work. Or they'll start saying, calculate normal force. You calculate normal force, you write it down. The next question, calculate frictional force. You calculate frictional force, you work it down. Then, so what we did here, we were working on close to calculating the normal force 3 marks, calculating friction 4 marks, that's 7 marks. Then calculating the coefficient, that will be 4 marks. So we're working on 12 marks here. Everything that we did is 12 marks. So I'm just trying to show you how to do this from the start. But in an exam, they'll bring it question by question. They'll start saying, calculate normal force. Which formula do we use? This formula. They'll say, calculate frictional force. Which formula do we use? This formula. So the only thing that you need to understand is that how do we draw a free body diagram? God bless you, sir. Thank you, guys. Thank you. We need to work. Nah? Easy. Yeah, it's easy. It's easy, man. It's easy. Let us look at how they will ask the question. I'm going to try and change the question this time. Nah? Let me try and change the question. We're going to take it step by step. Nah? Let's start with this one. Let's say that we have another object at inclined. This is my inclined, and I have an object here. Okay, so this force is applied, and the force applied, F applied, this is equals to 5,200 newtons. And then we have the force going down, which is my frictional force, Fk is equal to 1,800 newtons. Okay, so they give it to you like this, and they say that a car engine applies a force of 5,200 to keep the car moving up in the incline at a constant speed. So the car is moving at, then they'll say constant speed. They will write it in bold. I'll explain why they put it in bold. Now, they say that the car has the mass of 1,200 kg. Okay, so, and the frictional force acting on the car while moving is 1,800. So this is the information that we are given. Why didn't we use acceleration when we calculated the normal force? Nolo. Let me explain this. Nah? When we calculate the normal force, the reason that we did not use, what is this? The reason that we did not use acceleration is that normal force is a vertical forces. So when we calculate vertical forces, we just say F net is equal to 0. They have an acceleration of 0. Okay? Nolo, please always remember that net. They have an acceleration of 0. Okay, so now on this question, they said that number A, we need to answer number A. Draw a free body diagram. Draw a free body diagram. Okay, so we need to draw a free body diagram showing all the forces that are acting on the object. Okay. So when we draw a free body diagram, I'm going to draw my free body diagram. I need to indicate all the forces. Now, look at this. Already I have F applied going up. Then I have my Fk going down. Now, so guys, I'm going to advise you, when you draw a free body diagram, please do not include your components. Do not include Fg perpendicular, Fg parallel. But when you do for calculations, that's when you can include them. Né? So this is for 4 marks. Draw a free body diagram for 4 marks simply means that we need to show 4 forces. So therefore I'm going to have Fg going down. I'm just gonna call this Fg, but I think it's best if we do it correctly, so you guys can see what is going on here. Né? So the Fg, it's moving down, and then the normal force will go up. So these are the forces that I need you to indicate. I need you to indicate a force that is going up, which is your F applied. Then we're going to say a force going down. This is my Fk. Then a force that is going down. This is my FG. And then I'll have a force moving in that direction, which is my Fn. Please don't include FG perpendicular. Do not include FG perpendicular, and do not include your FG parallel. Only give them those forces. Nah? Okay. Okay. So now, if we keep moving, nah? If we keep moving, that is 4 marks. We can move to the next question. Let's see what they need us to do on the next question. So the next question says, calculate the magnitude of the car's weight down the slope. That is B. Calculate the magnitude of the car's weight down the slope. Guys, tell me, what should we calculate here? What are they looking for? Let's see. I want someone, I know that we are all smart, né? In the lesson. Everyone is smart, because remember, as batho but now I need you guys to tell me what you guys think we should calculate here when they say the magnitude of the car's weight down the slope. Look at the weight down the slope. The weight down the slope. What are they looking for? Come on, anyone, please. Tell me, what are they looking for? What are they looking for? FG. Moloko says W equals to mg. Okay. Come on, guys. Knowledge FG. Are you all saying FG? They're looking for the FG. Given, you also think they're looking for FG. Just FG, guys, because they said down the slope. Which weight is going down the slope? Please, I need you guys to think. FG is going down. Let's indicate where is FG going. Look at this. Look at where is FG going. FG is going down. It's going down. And then this is my slope. Which force, which weight is parallel to that? Come on, FG parallel, guys, please. FG parallel. We even indicated on the first one that the weight that always goes down the slope, it's FG parallel. FG parallel is what they are looking. It's what they want you to find. I'm not sure if you guys understand this. They are looking for FG parallel. Someone said FK. No. FG parallel, Mr. Bledwaba. I'm not sure if I'm saying this right, but yeah. So they are looking for FG parallel because FG parallel is the weight that is going down the slope. When you see the weight down the slope, when they say weight down the slope, just know that we are referring to this as FG parallel, guys. Yes, guys, thank you very much for the comments. Like, I see that you are trying, and I'm going to assist you. Thank you very much, guys. I love you guys, no? Yeah. Total weight of magnitude, FG parallel. Thank you, Evelyn. No, you don't have to delete your messages. We are learning here, ne? Yeah, I really appreciate you guys. So now, what is the formula for FG parallel? You know, next thing, one thing I need you guys, this is how, as a physics learner, this is how you should think. This is how you need to answer questions. When they say they want a force, they want you to calculate a certain force, you need to ask yourself, is this force a horizontal force or a vertical force. Look at FG parallel. So I'm going to draw my free body diagram. We need to indicate a free body diagram for all the forces that are horizontal to the plane. So now what I'm going to do, I know that here we're going to have another force going down, which is my FG parallel. How many forces that are parallel to the surface? We have 3 forces. I think everyone can see that. We have 3 forces. So I'm going to draw a free body diagram indicating those forces. So I'm going to say we have a force that is going up, which was F applied. So if you still remember, they said after F applied is going up. Then we have FG parallel. Then we have frictional force, which is my FK. Guys, listen. When they ask you for a certain force, make sure that you draw a free body diagram. So now why are we drawing a free body diagram for horizontal forces? Because we are looking for FG parallel. FG parallel, we need to indicate all the forces that are parallel to the surface, which is F applied, but also note the direction. Where is that force going? So now we can use the Newton's law and say F net is equals to MA. We choose direction. I'll take up as positive, meaning that all the forces that are going up will be positive. So we'll take the F applied, we subtract all the forces that are going down because they are negative. Why? Because we chose our direction up as positive. So this will be Fk is equals to MA. Right. So now you see that we can't, this is just easy marks. Look at this. Go back to your statement. Okay, do we have the F applied? Yes, we were given the F applied from the statement, and they said the F applied is equal to 5,200 newtons. I'm going to write it down here. 5,200 newtons. Do I have my Fk? Yes, which was given as 1,800 newtons. So now look at this. We have the F applied, tick. We have the Fk, tick. And we are looking for Fg. Do we have the mass? Tick. But do we have the acceleration? No. So now look at this. We have 2 unknown variables on our equation. We are looking for Fg parallel, but we don't have the acceleration. Will that work? No. How can we get rid of the acceleration? We go back and read the statement carefully. They say that the car is moving at a constant speed. So they put it in bold so that you can remember that, oh, if the car is moving at a constant speed, acceleration is equal to 0. So now we can see that this will be 0 times the mass, which will give us everything to be equals to 0. So now when I rewrite this, this will be my F applied minus Fg parallel minus Fk is equal to 0. Let's substitute. What is F applied? 5,200 minus Fg parallel, which is the one that we are looking for, with minus 1,800, and this is 0. So I'm going to leave the 5,200 this side, which we're going to minus 1.8. Let's take the Fg parallel to the other side. This was easy, né? Therefore, what is Fg parallel equals to, when you put it on the calculator? This should give you 3,400 newtons. 3,400 newtons. And we know that it's positive. This indicates that it's going down because we... Oh, let's avoid the direction there for now. Thank you, Evelyn. I see that you've been practicing. Now, that's very correct because you've managed to see the constant velocity. That's very correct, you see. Thank you very much. And we are done answering that question. Let's look at what do we have. Let's look at the next question. I'm going to look at the next question. What do we have? The next question says that we need to calculate the angle of incline. Okay, The angle of incline, they want us to find that angle, the angle of incline. Okay, that's question. What is this? Calculate the angle of inclined. Thank you very much, guys. So how do we calculate the angle of incline? Remember, I always say, let's study smart, guys. Let's study smart. Read the question carefully. Look at the question. What is the question saying? Angle of inclined. So when do we use the angle of inclined? When we find the FG parallel, which is mg, the sine of theta. When do we use the angle of incline? When we find the FG perpendicular, which is mg, the cos of theta. But now, this won't work because we don't have the FG perpendicular. Look at this. We don't know what to do. Go and refer on the previous question. You'll see that, man, FG parallel, I know what is FG parallel. And if I want to solve this, I can say FG parallel is equals to mg, the sine of theta. So I can just substitute my FG parallel as 3,400. If you still remember, we got FG as 3,400. So I'm just going to substitute that guy there. And let's equate this to the mass. The mass was given as 5. Oh, the mass was given as 1.2. So this is 1.2. What is this? This is 9.8. The sine of theta. So now we can just isolate everything. How do we isolate? We can divide both sides by 1.2 multiplied by 9.8. Therefore, divide this by 1.2, which is multiplied by 9.8. What's next? We need to find the sine of theta. What is the sine of theta equals to? It's equal to 3,400. I'm not going to put this on the calculator yet because I don't want to round off. This will affect my final answer. So theta will be the sine inverse of everything inside the bracket. You see, this is how easy it is. You just have to punch that on the calculator and find your angle of theta, the angle of inclination. So when we substitute that, what do we get? We get that our angle is equals to 16.81 degrees. This is our angle. Are you guys happy? Are you all happy with that? Thank you very much, Katleho. Thank you very much. Nolo, thank you very much for your answer. Are you guys happy? Thank you very much, guys. I see your answers. Some you did the honor now. Please pay attention to your roundings now. It should be 16.81. Maybe if unless if you made a typing error. Are you all happy? Can we answer the next question? Last question say, calculate the coefficient of kinetic friction. Between and the slope, between the car and the slope. Thank you very much. Thank you. Now I really appreciate those who are participating. Much appreciated, guys. But now look at this question. Remember I said when they want you to find something, you need to look at what are they looking for. Now look at this. So guys, we're going to use all the colors. I just like to do mix masala. I guess I'm the only one who doesn't understand. To slide, which part you don't understand? What's going on to slide? You want us to go back? Come on, this was straightforward. To slide, they're asking for the angle of inclination. And then we know that the angle of inclination, what I need you to ask yourself is that when do we use the angle of inclination? Remember, we said we use the angle of inclination for FG perpendicular and FG parallel. So what you need to ask yourself is that what do I have so far? I have FG parallel. I can equate this to what? To say this is mg, the sine of theta. I have this and they are looking for the angle. I can just substitute the mass and the gravitational force. Then I isolate what? I isolate the sine of theta. This is grade 10. Isolate, you see everything that we did. This is grade 10. Grade 10, where they were asking us to find the angle. We say angle is what you have to do. You need to know your algebra. Do the correct substitution. Isolate this guy. We are trying to remove everything this side so that we can only be left with the sine theta. So now that we have the sine theta is equal to 3,400 over 1.2 times 9.8. Our aim is to find theta. How do we find theta? The sine inverse. Inside the bracket 3,400. So this tells me that you need to go and revise grade 10's work where you are solving for angle theta. No, I'm sorry to slide. You know what you need to do? Remember, the recording will be available after the lesson. So this is the last question. So the lesson after, when we end, you can just go watch the lesson, stop, work it out to understand. Then if you don't understand, that's when you can reach out to me. I'll try to do voice notes and explain everything. Okay, so now this is the last question of the night. They want us to calculate the coefficient of kinetic friction between what? Between the car and the slope. This will be the last question for tonight. So look at this. I said if they want you to calculate something, kinetic friction, what is the formula for kinetic friction? It's Fk, it's equal to the coefficient times the normal force. But remember this thing is what? This thing is uninclined. The normal force will be equal to the opposite force, which is Fg perpendicular. So now look at this. The force is applied horizontally to the surface. It's not applied at an angle. This tells us that the normal force is just Fg perpendicular. So the normal force is just Fg perpendicular. So what I'm going to do, I know that my Fn is equal to Fg perpendicular. What is Fg perpendicular? It's mg, the cos of theta. Understand? So now, where there's Fk, I know that that will be 1,800. Where there's normal force, we need to substitute mg, the cos of theta. So now, we are looking for this guy. Let's do the substitution. Remember, Fk was given as 1,800. Close the bracket. Let's quickly confirm that. We had the frictional force. This is my frictional force. It was given as what? 1,800 newtons. So I'm just going to put it there and say this will be 1,000. It's equal to the coefficient. The mass of the car was given as 1,200 and 9.8. The cos of, now look at this. We have the angle of incline which was 16.81. This tells you that If you got the 16.81 wrong, this will affect your answer. This will affect your answer. So theta we calculated as 16.81 degrees. So now, what is next? Divide both sides by 1200 and 9.8, the cos of 16.81. Divide also this side by that 1200 into 9.8, the cos of 16.81. So these two cancels. What is the coefficient? You just have to punch that on the calculator and tell me what you get. So you need to put this inside your calculator, and then let's see what you guys get. 0.16. Thank you very much, Onalena. I see Onalena on this lesson. 0.16. You see? And that's it. That's how it is, guys. Please make sure that you subscribe, guys, on the channel. Make sure that we help the channel grow, because the more, if the channel grow, we'll be able to assist more learners. Yeah. So if we have more learners, this simply means that there will be more support for us. Let's make sure that we subscribe on the channel, because yeah, let's make sure that we subscribe on the channel. Do you guys have any question based on what we've covered so far? I just want to hear from you. Should we end the lesson? Should we continue? Let's see on the comments. No, let's continue tomorrow, sir. No, let's continue. Let's end the lesson. Do we have any learners going to school tomorrow? Okay, thank you very much. Thank you very much for confirming that. Guys, we're going to work on a very sensitive problem. Thank you for confirming and saying, you know what, sir, continue. We're going to work on a very sensitive problem, but I'm going to move this thing to the other side, and then I'm going to see how I can read your comments. Let me see this. Okay, guys. Let's continue. Yes, we're going to move. Don't worry. We're going to continue now. Let me see how I can. Okay, it's fine. I know where I can see your comments. It's fine. So now just give me a second. Let's continue. Yes, we're going to continue now, and we're going to work on a very. Oh, guys, wait. We are not done. We still have to calculate. Did we calculate the coefficient of? Wait, what's going on? Oh, we did. Yeah, Onalena, we are doing simultaneous equations now. Yeah, Onalena, thank you very much. We are doing simultaneous equations now. Just give me a second. We're going to work on simultaneous equations. I just want us to bring more learners to the party. Okay, let's work and see who will be the last man standing. Okay. What's wrong? What's wrong, FND? We are waking, don't worry. We are waking now. We are waking. Let's work on this one. This one has to do with we're going to call this problem connected objects. Okay, we're going to call this connected objects. So someone said let's do simultaneous equations, and you know what I like to do is that I don't like to focus on things that you guys do at school. Né? Right, you'll see that if I have maybe two someone said let's do simultaneous. I want to show you guys something here. You're going to see what we're going to do now. Okay, please tell me, guys, do you guys do like connected object at school? Did you do this with your teacher, like connected objects? I need to see your comments. Né? When we say connected object, you're going to understand how this works. Né? I have two objects that are on the surface like this. So these two objects, we call them connected objects. So now, yes, we're going to use simultaneous equations. Né? We're going to use simultaneous equations. We're going to do simultaneous. But now, what I need you to note on this, let's say the first block is 10 kg. And I have the second block as 15 kg. Right. So, from this, these two objects, they are connected and we have the F applied here. So we are given the F applied. I'm going to call this F applied, and let's see, the F applied is equals to 100 newtons. Right. That's what we know so far. Né? So now what I'm going to do, this is a 10 kg block rest against a 15 kg block on the rough surface. So I need you guys to note the following. This is a rough surface. This tells you that we have a friction. This is a rough surface. Then 100 horizontal force is applied to the 10 kg block. The 10 kg block experiences a frictional force of 7 newtons. So the 10 kg block, I'm just going to write it here and say the 10 kg block has frictional force Fk. Let's call this Fk. So I'm going to call this the frictional force of 7 newtons. I hope everyone is with me on that. Are you guys still with me? Sir, please repeat the last part. You want me to repeat the last part, ne? Okay. Wait. Don't worry, ne? We have been. I'm just giving you like. I'm still giving you the information on the block. We haven't done anything yet, ne? We haven't done anything yet. I'm still giving you the information. So the 10 kg has what? The 10 kg has 7 newtons. Then what about the 15 kg? The 15 kg block experiences a frictional force of 10 newtons. So this 15 kg block, it has Fk, that is 10 newtons. Okay, so now the question says determine. I'm just gonna write the question down. Question says determine the magnitude of the acceleration. Right, that's the first question. Determine the magnitude of the acceleration. Number 2, they want you to find the force, determine the force the 10 kg block exert on the 15 kg block. We're going to work on these two questions. Né? These are the questions that we're going to work on. First thing, we have two blocks that are connected, and then the force is applied. I'm going to explain why am I choosing this problem. Né? I'm going to explain why am I choosing this problem. So now, let me see if we have any comments on the other side. Yes. Okay. Thank you, Busisiwe. Thank you. Welcome. I can see your comments, guys. Né? Thank you very much. So now, what I'm going to do is that, remember, guys, now we are working on something different, and I need your attention on this. Né? This is where I'm going to need your attention. Listen, we are given two objects that are connected, and this is the information that we have so far. Remember that one thing I need you to remember first, these two objects are connected. Né? They are connected. There's no tension. We don't have any tension between the two objects. We don't have tension between these two objects. So now, what we're going to do is that, remember from Newton's third law, the force the 10 kg block exert. I think it's important that we put this down. Eh? From Newton's third law, if you still remember, according to Newton's third law, what is Newton's third law? How are we going to use this? Remember, we're going to say that the force, the 10 kg block exerts on the 15 kg block is equal to the magnitude of the force the 15 kg block. It's very important that you understand this. Né? The 15 kg block, the magnitude of the 15 kg block on 10 kg block. Guys, what we are trying to say is that the force applied by the 10 kg block on the 15 kg block is equal in magnitude to the force applied by the 15 kg block on the 10 kg block. That's Newton's third law. I'm not sure, guys. Can you please confirm if you understand that part, please? Oh, I'm sorry, guys. I'm not sure what happens to your charts. Okay, let me try to... Guys, are we still live? I don't see your comments. Can you please tell me if we are still live, guys, on your side? I'm not sure what I did. Please tell me. Can you comment if you are still live? Say yes. Okay, Onalinda, well explained. Guys, if we are still live, I need to see your comments, please. Say yes, we are still live. I don't know what I did to your... Okay, thank you. So you guys can see the screen, eh? Yes, we're still live. Okay, sure. Thank you very much. Let's go back to the question. So now, this is very important for you to understand that the force, the 10 kg block exert on the 15 kg block, we say it will be equal in magnitude to the force the 15 kg block exert on 10 kg block. So now what I'm going to do, first thing first, start by drawing a free body diagram. Né? Let's start with the 10 kg block. Look at the 10 kg block. I'm just going to redraw those two blocks here. We have two block 1 and we have the second block like this. Right, so this is 10 kg block and this is 15 kg block. Okay, so now look at these two. I need you to first draw a free body diagram. So now you see these two they are in contact. Né? When they are in contact and we need let's start with the 10 kg block. I need to take the 10 kg block and draw a free body diagram on that 10 kg block. Okay, so what I'm going to do is that I'm going to say that I will have F applied. Remember, this is my F applied. This is my F applied. And it was given as 100 newtons. So the F applied will go in that direction. Right, this is my F applied. We are drawing a free body diagram for the 10 kg block. Then this block will move to the right. Where is the frictional force going? To the left. So this is my Fk, my frictional force. But remember, these are not the only two forces acting on the block. I need someone on the comments to tell me which force that is acting on the block. Husisiwe, welcome, Smoloko, Moluku, Wipilo, Wafana. I'm just going to read your names, those who are on the YouTube live. I'm just going to read your names. Onalena, Evenly, Knowledge, Noko, if you guys are still in the lesson, Zwanga, Bonnie, please, if you guys know the answer, please tell me. There's another force that is missing here. Tell me which force is missing. Which force is missing? We are missing a force here. Fg and Fn. I need horizontal forces. Né? Let's focus on horizontal forces because we're going to use simultaneous. I'll tell you when to bring the Fg. Look at this, guys. Remember, we just said that the force the 10 kg block exert on the 15 kg block is equal in magnitude to the force the 15 kg block exert on the 10 kg. So this tells you that here, whatever force that is applied by 10 kg block, the 15 block will apply that force in an opposite direction. So this tells us that we're going to have a force that is going in that direction, and we're going to call that force the force of 15 kg block on the 10 kg block. I'm not sure if you guys understand, but I'm going to move this thing here, and let's move the Fk here. I'm just going to write the Fk on top so I can explain this properly. So this is my Fk. So what I'm saying is that this other force that we are missing, this force, it will be the force of 15 kg block on 10 kg. It's very important. So now, if you understand this part, this is where everything starts to get interesting. The free body diagram. So the force that will go in that side is the force of 15 kg block on what? On the 10 kg block. So let's say that we need to draw a free body diagram for the 15 kg block. Look at this. For the 15 kg block, guys, don't make a mistake. We don't have applied force on the 15 kg block. The applied force, it's only applied to the 10 kg block. So someone will say the applied force is on the 15. That's wrong. Please make sure that you pay attention on that. So now, if the force of 15 kg on the 10 kg is going to the left, this tells you that the 10 kg block, this will be the force of 10 kg on 15 kg. So what I'm trying to say is that they'll go in an opposite direction. If you understand this concept, everything is good. You are ready, ne? If you understand the concept, then you are ready. Trust me. I just want you to understand what I'm currently explaining now. So now, the 15 kg block will explain what? A frictional force that is opposing the motion. So this will be my Fk. I hope you guys understand. I'm just gonna stop here. Just if you guys have any questions. Right, I'm just gonna ask, guys, why do you delete your comments? Please don't delete your comments, né? I'm just gonna stop here. I just want to see if you guys have questions, because the free body diagram is very important. It's very important that you understand the free body diagram. If everyone is happy, then we can continue, né? So now look at this. We have two free body diagrams. Now we can, one thing I need you to do, né? Let's let the, remember, these two forces are equal. Okay, let me, okay, I'm saying that these two forces are equal. So since they are equal, we can let the magnitude of the 15 kg block on the 10 kg block to be x. So what I'm saying is that this force, we said they are equal. So I'm just going to let it to be x. Please, let's let those two to be x. So if we let that one to be x, what are we going to do next? Now we can start using Newton's second law. First thing first, we choose direction. I'm going to take right as positive. So if we take right as positive, this will be F net. It equals to MA. Now, all the force that are going to the right will be positive. I'm going to take my F applied. I need to minus my kinetic friction. I need to minus what? X. Why? Because this force here is X. Then we're going to equate this to MA. Remember, force of 10 kg block on 15 kg block is equal to the force of 15 kg block on the 10 kg block. So now we can substitute what we have. The F applied was given as 100 newtons minus Fk. What is the kinetic for the 10 kg block? It was given 10 kg block is 7 newtons. So we're going to minus 7 newtons. So I'm just going to come and write it here and say this is my 7. We minus x is equal to the mass. Remember what is the mass? This is for the 10 kg block. So this will be 10A. I hope everyone is happy with that. Let's make x subject of the formula. So 100 minus 7, that's 93. Let's take the 10A to come this side to be negative 10A, and then this is equals to x. I'm going to call this equation 1. So what we did is that we moved the 10 to the other side to be negative, the x to the other side to be positive. So that is equation 1. We need to go and work. Remember, this is for what? This is for the 10 kg block. We need to go and apply the same way. We need to go and apply the same on the 15 kg block. F net it's equals to MA. Then what is my F net? I take right as positive, all the forces that are going to the right minus all the forces that are going to the left, equate this to MA. So this will be X minus, we know that the frictional force for the 15 kg block, it was given as 10 newtons. So that was given as 10 newtons. So I'm just going to substitute 10 newtons and say this is X minus 10. It's equal to the mass of 15A. So I'm just going to leave this like this and say this is my equation 2, because I know that what is X? I know that from equation 1, I have the value of X as 93 minus 10A. So where there's X, we can substitute what? We can substitute that as 93 minus 10A. So what is the most important thing, guys? The most important thing is for you to draw the correct free body diagram. Say, what is the dielectric constant? I'm not sure what is that dielectric constant. I'm not sure what you are trying to say now. Okay, so now we know what is X. We know that where there's X we can substitute. So what we're going to do, we're going to sub X equals to 93 minus 10A into equation 2. I hope everyone is with me on that. So let us quickly go and substitute. So when we do the substitution, remember, rewrite the equation first so that you don't make mistakes. Né? So this will be X minus 10. It's equals to 15A, meaning that where there's X, we can put 93 minus 10A. We still have minus 10. This is equals to 15A. Then what's next? We group the like terms. 93 minus 10, what is that equals to? That will give us 83. It's equal to the 10 will go to the other side to be 15 plus 10, which will give us 25A. Divide both sides by 25. Divide by 25. Therefore, what is the acceleration equals to? Therefore, our acceleration is equals to, what do you guys get on your calculators? What is dielectric? I'm not sure what you are asking there. So what do you get as your acceleration? Okay, so this gives us 3.32 meters per second squared. We're done with the first question. The first question said determine the magnitude of the acceleration. We have the magnitude of the acceleration. The next question says determine the force the 10 kg exert, the 10 kg block exert on what? On the 15 kg block. So you can see that this is just the same thing. Né? This is just the same thing. Remember we said this guy here, this force, which is X, it equals to that force, which is X. So we know that we just have to find the value of X. The value of X is the force the 10 kg block exerts on the 15 kg block, and it's also the force the 15 kg block exerts on the 10 kg block. So what you're going to do now, you're going to substitute. Let's do the substitution. We're going to substitute A is equals to 3.32 meters per second into, so let's quickly go and check. Remember we know that the value of X is what? Okay, maybe let's substitute where? Equation 1 into equation 1 into equation 1. So equation 1 was 93 minus 10A, which was equals to, let's quickly confirm that it was 93 minus 10A is equals to X. That is X. So X is 93 minus 10. Where there's A, I'll put 3.32 and then this is equals to x. So guys, tell me, what is the x equals to? I need to see the comments, guys, on YouTube. Those who are watching from YouTube, what did you guys get? Those who are watching from YouTube, what did you guys get? 59.8. Did you all get 59.8? What about the direction? I can see you guys say 59.8. What about the direction? 59.8. What about the direction, guys? Those watching from YouTube, what about the direction? 5.98. Where is this going? Because this is very important, for us to indicate the direction. 5.98 newtons. Left. We're always saying this is going to the left. Remember the free body diagram, left. Everyone is saying to the 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 left. Guys, you need to pay attention. Let's go back to what is the question saying. The question said, find the force of 10 kg block that exerts on the 15 kg block. You see, 10 kg block on the 15. Remember we said this is the force of 15 on the 10 kg. So the force of 15 on the 10 kg, where is that force going? That force is going to the left. And we are not looking for this force. So this force here is going to the left. That is the force of 10. They are looking for what? The one that is going to the left is what? The one that is going to the left is the force of 10 kg on, or of 15 kg on the 10 kg. We are looking for this. Look at this. Look at the question. Calculate the force of the 10 kg on the 15. And we said the one that is the 10 kg on the 15 is this one. Where is this going? To the right. If you say left, you're going to lose a mark. So now this is equals to 50. We got 59.8 newtons to the right. Are you all with me? Are you all happy about that? Please guys, I need to see welcome is saying to the right side, because they said 10 kg block on the 15. Guys, I'm happy that you are paying attention. Those who are watching from YouTube, thank you very much. I see that you guys 110 kg. Yes, thank you, Evelyn. Thank you very much. So that's how we work on this question. So tell me guys, do you have any question based on this problem? Thank you, Bini Jesus. Do you guys have any question based on this one? Okay. So, I want us to look at a hanging object. I want us to look at a hanging object. So when I say a hanging object, let's say that you see these two guys, you see these two blocks, the 10 kg block and the 15 kg block. We're going to change these two and we're going to put them where? We're going to put this thing on there. Maybe we can put the tension in the middle. We can put the tension, then we're going to take the 15 block, then we're going to drop it down so that it can be like hanging, so that when it's hanging, the only forces that will be on that one, it will be what? The only forces will be the vertical forces. I hope everyone is with me on that. I hope you guys understand that part. Let's just check on YouTube if we don't have any comments. Same answer, different calculations. You are totally understood. Okay, thank you very much. These are the comments from the YouTube part. Thank you very much. So now, what we are good set. Sure. So you know what we're going to do now? Let us do this. Let us take the 15 kg block. We need to bring it down, and then I'm trying to say that we're going to put it like this, and say this is my 10 kg block, and then we're going to bring it down there like this with the tension. Let's drop that 15 kg block. Then we need to work on questions that will be asked. Let's drop that 15 kg block, and this will be my table. I'm sorry guys, I'm not good at drawing, but it's fine. I think everyone can see my drawing now. So this will be the 10 kg block, and we have the 15 kg block. Okay, listen to this. The 15 kg block is connected to a 10 kg block by what? It is connected by a light intensible string running over a frictionless pulley as shown in the diagram. The force of friction between the table and the 10 kg block is 7. So this 10 kg block, the 10 kg block has Fk, the frictional force of what? The frictional force of 7 newtons. So the 15 kg block, this one, it only has tension and Fg that are acting on that block. So I need us to use this information to calculate. Let's calculate the magnitude of the acceleration of the system. And then that's the first question. Second question, calculate tension. I think we can all see this now. I think we can all see this. We're going to calculate calculate the magnitude of the acceleration of the system, and then we calculate the tensional force. Right, let's do this. First thing first, remember what is important: the free body diagram. The free body diagram. So what is important is that we need to find the free body diagram. I'm just gonna say, let's start with the 10 kg block. We need to indicate the horizontal forces. Remember, I'm going to have a tensional force going that direction, and then a friction going in that direction. So this will be my Fk. So when I draw a free body diagram, I'm going to say for the 10 kg block, we have the tensional force in that direction, and then we have our Fk, right, which is the kinetic friction. Okay, so what's next? Let's draw a free body diagram for the 15 kg block. The 15 kg block, look at this block, look at this 15 kg block. We have tension that will move up, then this is my tensional force, then I'm going to have my Fg going down, force of gravitation. So I'm going to draw my free body diagram here. I have the tensional force, and we have our Fg. Okay, everything is good so far. So now, let's start with this. For this one, let's take right as positive. Right, if we take right as positive, we use the formula F net is equals to MA. For 10 kg block net, we set right as positive, we'll take the tensional force, we minus all the forces that are going to the left, and let's equate this to MA. So what is my tensional force? It's 10 minus FK. What is the frictional force for the 10 kg block? Remember, it was given as 7 newtons. So I'm going to subtract this. I'm going to subtract 7 newtons. So let's just say 7. It's equals to mass, which is 10 times the acceleration. Let's call this, or maybe let's make the tension subject of the formula and say this is 10A. We add 7. Let's call this equation 1. Okay, everyone is happy about that. So now we need to work on the other. We need to work on the other guy, which is what do we have this side? So this side, remember, this is what I need you to take pay attention on. If this part we said we take right as positive, look at how this thing is moving. Can you see how this thing is moving? So if we take right as positive, we are forced to take down as positive. We don't have a choice, but we are forced to take down as positive. So now for this one, we're going to take down. Down will be positive. So this is another thing that you need to pay attention on. So we're going to use the formula F net. It's equals to MA. We set it down as positive, so it's Fg minus all the forces that are going right. So now look at this. This one is equals to MA. Right, guys, why is this equals to MA? Because someone, when I still remember on YouTube, someone asked, okay, so nice, Nolo, I see you guys already did the question. You guys already have you already have the answer. You got 5.6, that's your acceleration, and you got your tension at 63 newtons. Nice. Well done. Let's see if we get the same answer as this learners. Let's work on it and see if we get acceleration as 5.6. Let's work and see if we get that tension as 6.63 newtons. So what's next is that the reason that this is remember when the force is on when the force is in contact with the surface, that's when the horizontal force are equals to 0. But now this one is not in contact, so it won't be equal to 0. We need to say this is equal to F net is equal to MA. So this is mg, which is the mass times the gravitational force. We minus the tension is equal to 15A. So what's next? What is the plan here? What is the plan? We need to make the tension subject of the formula, or we can just go straight and substitute our tension. So what I'm going to do, I know that 15 times 9.8, that gives us 147 newtons. We minus tension, this is 15A. So I'm just going to call this equation 2. So now look at this. We already know what is our tensional force. We already know what is tension. So we can sub in equation 1 into equation 2. So now this will be 147 minus tension, it's equals to 15A. Remember, I don't want to make mistake, so I'm going to start by rewriting my equation. So this will be 147 minus, I need to put it inside the bracket. I know that tension is 10A plus 7, so I'm going to put it inside the bracket. So this will be plus 7, it's equals to 15A. So we can work on this. We can quickly work on this and say this is 147. I need you to multiply out the bracket with a negative. So this will give us minus 10a minus 7, it's equals to 15a. What's next? We just have to group the like terms. So 147 minus 7 will give us 140. This is equals to 25a, because the 10 will go to the other side to be positive. Now what's next? I can just divide both sides by 25, divide the other side by 25. What is acceleration is equals to? So we get the same answer as the comments that we got on YouTube. So this is 5.6 meters per second. Right, so we call this equation 3. Why is this equation 3? Okay, we don't have any comments on TikTok. Okay, it's fine. So now, why is this equation 3? This is equation 3 because remember the question said find the acceleration, and now they want us to calculate the tension. So I'm going to calculate the tension. I can substitute this in any of this formula, but I'm going to use equation 1 to find my tension. So tension is 10a plus 7. So I'm going to say my tension is equal to 10a plus 7. And then if it's 10a plus 7, I can say, what is that equals to? It was 10a plus 7. So let's substitute. The tensional force is 10 into acceleration, which is 5.6. Everything closed, we add 7. So when you punch this, we get, what do you get? When I put this on my side, I get 63 newtons. And that is the final answer. I'm happy, guys, that we moved until we pushed the hours until for 2 hours. We're sitting on average view duration of 7 is to 7, let's just say 7 hours, and then we have views close to 468. I see today you guys came in numbers. Views, current viewers now, we have 21 learners, 21 what is this, last man standing, 21 last men standing on YouTube. There's 21 learners, guys. I need you guys to tell me what do you think about today's lesson so that we can improve on the next lesson. Right, we have 21 learners last standing, guys. This is where we're going to stop for today. This is where we're going to stop, and thank you, guys. I see you came in numbers. This is where we're going to stop for today. I just want to see your comments, your questions before we end the live. Thank you, sir. Thank you, Evelyn. It's a pleasure. Thank you for joining. It was amazing, sir. Yes, it was amazing. So if you want to watch the recording next time, it will be available on YouTube. It was great. Today's lesson helped me a lot. No, please don't stop. When you practice, go and watch the lesson again. Go and watch the lesson again. Excellent lesson today, sir. Much appreciated. It's a pleasure. Thank you, guys. Thank you, and this is where we're going to stay. You helped me with the concept I never understood. Thank you so much, sir. Please make sure that you subscribe on the YouTube channel. Now remember, let's help the family to grow. So when are we going to do maths? Guys, I have something good for you. Remember Sundays, I need you to go to church on Sunday. Make sure that you come back early, because Sunday we're going to do long hours. Don't worry. Sunday, make sure that you don't have network problems, Sunday we're going to do long hours. Say I sent you a message on WhatsApp. I'd like to join a group. Oh, it's fine, Tulu fellow. When did you send the message, Tulu? When did you join the message? Guys, Sunday, tomorrow, let's take a break. We'll see. I'll confirm about tomorrow's lesson. I'll definitely confirm on Tuesday. Tulu, I think if you say you send me a message on Tuesday, I did add you on the group. The lesson was excellent, sir. Thank you a lot for your assistance. It's a pleasure. Bonnie, best, sir. We are getting this. Yes, get in, Bonnie. Get in. We need those distinctions, ne? We are getting those distinctions. Your classes are lit. Yeah, we are getting those distinctions. Guys, please go and review. I get it on maths. We are focusing on trigonometry for grade 12. And so if you are doing grade 12, go and study the basics, because we're going to work on, we'll continue with identities. Ne? Yeah. So, given, get in. Thank you very much. Yeah, thank you guys. We'll communicate on WhatsApp. Thank you for joining them. I'm just gonna end the lesson now. Much appreciated for the learners who stayed for the 2-hour lesson. Sharp guys. Thanks. Wow, that was a massive lesson, guys. We were